Namaskar and welcome to StudyIQ. I am your friend Rahul Saigaonkar. Let's continue our discussion of NCERT Science series. You already know we are into the discussion of NCERT Science textbook for class 10, where we are proceeding with the discussion of each chapter. Until now, we have discussed 4 chapters. I hope that you have seen those video lectures. In chapter 1, we discussed chemical reactions and equations. In chapter 2, we discussed acid, bases, salts. In chapter 3, metals and non-metals. And in the latest interaction, we discussed about all important carbon and its compounds. Today, we will be discussing about chapter 5, that is periodic classification of elements. Now, by this, we would be completing one chunk of our syllabus. I told you in our first class, from chapter 1 to chapter 5, we will be having the discussion of chemistry. So today, we'll be completing our chemistry discussion from class 10. In fact, this chapter 5, it has been in news. I hope that you must have heard about this, right? In recent times, we had a news that the government has eliminated the periodic table from NCERTs. There was a lot of hue and cry about that, because we are discussing the chapters from the old syllabus. You do know that from 2022-23 academic year, we have seen the rationalization of syllabus, and I think in the new NCERT there are some chapters which are cut off. I think there are only 13 chapters, and one of the chapters which was eliminated was periodic classification of elements. Although NCERT did give explanation that these ideas or this syllabus is again there already in the class 11 as well, but it was in news, right? There was a lot of politics around it. Let's leave that politics apart. Let's focus on science. Now, in this chapter 5, we will be understanding the evolution or the development of the modern periodic table, how people in earlier times classified elements, and how we have arrived till the modern periodic table. That's the basic agenda. Let us begin our interaction. But before that, there is a small notice for all of you. StudyIQ is giving you Prelims to Interview Initiative. This is the most comprehensive and the most integrated program for UPSC civil service preparation. It is very affordable. If you want maximum discounts, you use my code Rahul Live on it. It is available in 3 formats according to your convenience: in English, in Hindi, in bilingual format, that is English. The classes are starting from 22nd July. Do enroll. Just visit our website studyiq.com and enroll for this program. I'll see you in the class and will prepare for UPSC civil service exam. All right? Right. Let's begin. As I told you, our discussion is about periodic classification of elements. Now, where have you heard this term element? In our earlier interactions, we discussed about pure substances. Do you remember? We discussed pure substances, and one of that was element. We saw mixtures there. Mixtures are not pure substances. Elements are pure substances. And why did we say elements are pure substances? Element. Now, element, it contains atoms of only one type. Atoms of only one type. For instance, I say oxygen. Oxygen as an element, it contains atoms only of oxygen, no other atoms. All right, those are pure substances. And throughout our history, slowly and steadily, we came to know about more and more elements. For instance, we came to know about iron during the Iron Age. During the Chalcolithic Age, slowly we came to know about copper. From ancient times, we knew about gold, silver, very valuable elements. We knew that gold and silver, they do not react much, but there are some other elements which react. So slowly and steadily, we were building our database of chemicals, database of these elements. Today, if we talk about different elements, there are about 118 elements, and majority of these elements, they occur in nature. Some of the elements have been synthesized in the lab. But since the beginning of the modern period, different scientists, different chemists, they started their voyage of classification of these elements. Now, they thought that some elements, say like gold and silver, they do not react. But some elements, say chlorine, bromine, others, they immediately react. So can I categorize these elements into one group or some kind of classification where I get to know more about the properties of these elements if I group them together? So classification always helps. All right. So scientists began classifying. Initially, there was very crude level of classification, but slowly and steadily that classification or the categories, they refine, and today we find modern periodic table. So what are we going to discuss in this chapter? We are going to discuss the journey of making order out of chaos of different elements. So how have we developed modern periodic table? Initially, scientists like Dobereiner, they gave different laws. He simply classified them as triads. From Dobereiner's triads to Newlands law of octaves. Again, a very non-scientific idea, but quite effective. We'll talk about Newlands law of octaves. Then Mendeleev, the Russian scientist who laid the foundation of modern periodic table, I can say. So he gave Mendeleev's periodic table. Later on, we improved over that, and mostly later on Niels Bohr, they contributed a lot towards the evolution of modern periodic table. So this has been the journey of classification of elements. So let's try to understand one by one. First one is Dobereiner's triads. Johann Wolfgang Dobereiner, by name itself, a German chemist, a German scientist. He studied in University of Strasbourg. So he attempted, one of the earliest ideas was to attempt classification of elements which can be clubbed together based on physical and chemical properties. So what Dobereiner did was he gave the law of triads. He said that he can group elements which have similar chemical properties, similar physical properties on the basis of the atomic mass. Remember, he categorized on the basis of atomic mass, and he put them in categories of 3. Triads means 3 elements put together. Right? He gave a law. Dobereiner's law of triads, it basically says that elements, when arranged in the ascending order, that means increasing order of their atomic weights or atomic masses, you will see that the middle one, the middle element, will always be or will always have the mean of the atomic masses of top and bottom. That's the basic idea. And it is quite impressive. Now, if you look at his time period, it is 1780 to 1810, probably just the beginning of 19th century. So at that time, he categorized or he grouped elements into one category on the basis of their physical and chemical properties. Look at this. Now he categorized lithium, sodium, and potassium. He put them in one triad or one group, and they have similar properties. Yes. And he said that if you look at their atomic masses, people at that time knew atomic numbers and atomic masses. Slowly and steadily, that idea was known. So categorization is based on atomic mass here. If we take average of first and the third, you will get the second element. That is what Dobereiner said. Right? He gave 5 triads basically. Initially, he only gave 3 triads. Calcium, strontium, barium were put in one group. Chlorine, bromine, iodine, quite impressive. Halogens were put in one group, where you can see if you take the arithmetic mean of first and third, then you will get the weight, closely the weight of the second one. Not very accurate, but still we need to give him some credit. He also created other groups like sulfur, selenium, tellurium, iron, cobalt, nickel. Again, these metals, they were put here. All right. Now, you already understand that there are a lot of limitations, or there are a lot of limitations of Dobereiner's triads, right? Now, what are the limitations? First of all, very limited amount of classification is done. Very limited amount of classification is done, and it does not hold true for other elements which were slowly and steadily being discovered. So what happened was another method of classification was developed. Now, this was developed by John Newlands. John Newlands was a British chemist, and at that time in 1864, when he gave his Newlands law of octaves, there were about 62 elements that were known. So what he did was he arranged these 62 elements from 1 to 62 in the ascending order of their atomic masses, again on the basis of atomic weights. Please remember, I am specifying here atomic weight or atomic number. Again, Dobereiner, atomic mass, same with Newlands. He arranged them in ascending order of their atomic masses, and he said that every eighth element has similar properties. That is basically the law of octaves. Law of octaves states that elements that are arranged in ascending order of their atomic masses, every eighth element has comparable properties, comparable physical and chemical properties. Now, this was quite interesting. Now, you would be thinking, why did he say every eighth element, and is there any merit to it? See, Newlands concept of these octaves was based on the musical notes. Now we have musical notes, sa, re, ga, ma, pa, da, ni. Those are 7 notes. So he said after 7 the eighth note or the eighth idea. That's why it's law of octaves. Now, very similar to how we have sa re ga ma pa da ni. In the Western tones, they have do re mi fa sol la ti. All right. So when he categorized, when he created this table, he categorized and he put eighth element in one particular group. You can see here, fluorine comes here, chlorine comes here, bromine comes, but some other elements also come. But you will see that to some extent, yes, okay, we can understand, because we do know the idea of octet now. Now we can talk about octet, because every element, it tries to achieve that stable configuration or stable octet that the noble gases have. So based on these musical notes of sa re ga ma pa da ni, he said that every eighth element, its physical and chemical properties would be comparable. But there are many loopholes in this particular theory. First of all, the entire idea itself is non-scientific. So many scientists, they initially ridiculed this idea of how can elements be classified on the basis of musical notes. So scientific community was a little skeptical about that. Apart from that, you see a big loophole here itself, where you group hydrogen, and hydrogen again, in the modern periodic table also, hydrogen has a very peculiar position, number 1 itself. You will see that. But fluorine, chlorine, bromine, this is very fine. But what are cobalt and nickel doing here? That's a question. There are many loopholes, and again, his idea, it holds true up to some level, only up to calcium, right? Only up to calcium, it is quite okay. But after that, slowly and steadily, the law of octave fails. The law of octaves, it fails. Added to this, if you see the time period, many new elements were continuously being found out. So one of the most important attempts towards classification was done by Dmitry Ivanovich Mendeleev. Now he started classifying the elements not just based on their atomic mass, but even looking at some other properties, and he created his own periodic table, right? Periodic table. Why? Because Mendeleev's principle, it first of all rejected Newlands law of octaves. He did agree that the periodic table elements, they have to be classified, they have to be based on atomic mass. Agreed. But not just atomic mass. Apart from atomic masses, we will also look at some of the fundamental physical and chemical properties. And based on these, that is based on the atomic mass, based on the physical properties and chemical properties, what Mendeleev did was he created a table. Now, when you create a table, you do understand table has certain rows and it has certain columns, correct? So the rows that he created, he gave them the name as period, and the columns that he created, he gave them the name as different groups. That means he put elements in different groups and in different periods. So what he created was, he created a table like these. That means groups. There were different groups like group 1, group 2, group 3, 4, 5, 6, 7, 8. He created 8 different groups, and he created periods in the vertical side. And he started to fill these elements. And by that time, more than 60 elements were already known. So he started to put these elements, say hydrogen was put here. Then there is lithium, beryllium, boron. So he characterized them through periods and groups. Please remember, Mendeleev's periodic table, it laid the foundations of our modern periodic table. All right, let me just show you Mendeleev's periodic table in a different format. These blue boxes that you find, these were the elements that were already known to Mendeleev. Please remember, when he created the table, he did not know about these noble gases. When he created the table, he did not know about gallium, he did not know about germanium, he did not know about all these elements which are there in red. But despite that, he created the table and he left these things empty. Based on his observation, he said there should be some element, he left them empty, and he said we will find them very soon. All right. So Mendeleev has contributed a lot towards the development and classification of different elements. That is why there are a lot of achievements. While developing the table, first of all, there were some anomalies. Of course, there were some anomalies. For example, the atomic mass of cobalt and the atomic mass of nickel, they have been mixed, they have been interchanged, but there are different anomalies also, because when you are dividing or when you are classifying on the basis of atomic masses, this was bound to happen. Apart from that, Mendeleev also saw that there were many gaps, because as you can see, there are so many red things which are not known. And for your reference, you can see what Dobereiner did initially. Dobereiner triads, these are the first Dobereiner triads, this is the second Dobereiner triad, this is the third triad, this is the fourth triad. You will see that these triads, they come under same groups. So you can see that Dobereiner was actually on the right track, but the concept of tabular format, or he did not evolve a more sophisticated kind of classification. So Mendeleev did it. You will see they align, right? They align to some extent. But Mendeleev's biggest credit goes to anticipating, or I would say forecasting, that we are going to find some other elements which are not known to us today. In fact, he named them also wherever they were missing. For instance, there is aluminum, there is silicon here. He saw that below silicon, below titanium, there were some things which are missing, right? There is scandium, gallium, germanium. They were not discovered by that time. He named them without knowing them. What he said was, we will find some element called as eka boron. This is the Sanskrit term. You do know Sanskrit numerical for one is eka. So he named them eka boron, eka aluminum, eka silicon, eka. Later on, when we discovered them, these eka boron, eka aluminum, eka silicon were appropriately replaced by the elements that were discovered, and based on the different nomenclature. So that is the biggest credit or biggest achievement of Mendeleev, that he anticipated there are some elements, there are some loopholes in my table, but he did not stop there. He gave that table, and later on we slowly and steadily filled it as well. But there were certain limitations as well. The first and the biggest limitation with Mendeleev is this hydrogen atom. Now, when you look at this, he put hydrogen in the first group itself, along with lithium, sodium, potassium, and you can see in the first group you have copper and you have reactive metals. You also have noble metals like gold, silver. There is gold, silver, and other metals. Now you will see platinum on the other side. There are some loopholes. All right. Now these are some of the issues. First of all, hydrogen. Where would you place hydrogen? Hydrogen is one of the biggest flaws or biggest issues with Mendeleev's table. Apart from that, the isotopes were not discovered when Mendeleev gave this periodic table, or he would have further refined his table for sure. But Mendeleev's periodic table, it laid the foundation for our modern periodic table. Now, modern periodic table was developed by Henry Moseley, where Henry Moseley proposed that we need to classify, or we need to put in a tabular format, the elements not on the basis of atomic mass, but on the basis of atomic number rather than atomic mass. Because by this time, different scientific equipment, X-ray, different experimental setup were developed, and Henry Moseley's law is basically dependent on the frequency of the emitted X-ray by that element in the X-ray experiment. He said that the frequency of the emitted X-ray, it depends on the atomic number of the element and not the atomic mass. Please remember that the modern periodic table, it is based on the atomic number rather than atomic mass. And that atomic number, again, we can cross verify that through the X-ray experiment. This was given by Henry Moseley, and later on the entire periodic table and new elements, they were further added, and the periodic table was developed by Niels Bohr. And what we find today as the periodic table is basically this. We have seen this before also in our interaction when we discussed metals, non-metals, and metalloids. I have told you that these red, they indicate metals, the blue ones, they are non-metals, and somewhere in the middle, boron, silicon, germanium, arsenic, these are tellurium, these are metalloids. All right. Now let's look at this periodic table, and you need to understand that this is based on the classification of atomic number. Atomic number is the identifier. Now this periodic table, it has different periods. As I told you, periods. Now, when we looked at our Mendeleev's periodic table, we saw that he divided the table in different periods and different groups. Now we have taken the same template that Mendeleev developed in the modern periodic table also by Moseley. We have different periods. We have 7 periods. We have 7 periods. Now periods are these horizontal rows. Periods are the horizontal rows. All right. Periods are these horizontal rows, and groups are these vertical columns in the periodic table. And we have 18. We have 1 to 18, and the periodic table should be read in this direction. From period, you will see atomic number 1 is your hydrogen, atomic number 2 helium. The atomic number is written here, and you will see lithium, beryllium, boron, carbon, nitrogen. So proper classification based on physical and chemical properties has been done in the modern periodic table. There are 7 periods and 18 groups, and on the basis of this, different groups based on their physical and chemical properties. If you look at this, the 18th row is of the noble gases. You will see helium, neon, argon, krypton, xenon, radon, oganesson. Then you have halogens here. So different groups, you will see they have similar kind of chemical and physical characteristics. And as I told you, majority of these are metals, and this series has the period 6 and the period 7. There are 2 series called as lanthanoid series and actinoid series, and many of these have been rather synthetic elements that have been discovered. But let's look at some of the characteristics of these periodic table. Again, from UPSC civil services perspective, you don't need to focus too much on the periodic table or mugging up or anything like that. All right, what you need to understand is some of the characteristics. Now when I look at any period, what do I see? And when I look at any group, what do I see? See, in a group, I told you they have been categorized. I say halogen, noble gases, etc. But when you look at a period, how valency, how atomic size, and how metallic nature varies. If you look at the valency in a period, if I see this particular period, the valency it increases. That means it goes from 1 to 4, and again it decreases. It goes from 4 to 0 again. And why 0? Because these are the octets. They do not react. Absolutely 8. The last electron shell will have 8 electrons in it. So it increases 1 to 4, again 4 to 0. Apart from that, when you look at a period, the atomic size decreases from left to right. Now this is a very important pointer. Please remember, in a period, the atomic size, it decreases. What is the atomic size? Atomic size means this is the nucleus, and the last electron shell that you get, if you say this is the last electron shell, then this defines you the atomic radius. From the center of the nucleus, this defines the atomic radius. Now the question is why does the atomic size decrease? This is very interesting. Now if you look at the elements in a period, you will see, say, take potassium, calcium, scandium, titanium, vanadium, whatever you take, you will see that the atomic number, it increases by 1, right? Atomic number, it increases by plus 1. That means the number of proton, it increases by 1, and the number of electron, that also increases by 1. Correct? The number of electron, that also increases by 1. Now if you look at this, if the number of protons increases, then the size of nucleus would increase. But when an electron is added, is another shell added to it? The answer would be no. If another electron is added, then the same electron will go to this shell itself until and unless that shell is filled. So what is happening? The nucleus size is slowly increasing, but since the nucleus size is increasing, meaning the attractive force of nucleus is also increasing, because of which the electrons would be attracted more and more, and that's why you will see decrease in overall size of the atom. That means the atomic radius will decrease slightly. I hope it's clear. All right. Now apart from that, metallic nature, the metallic nature of element, it decreases as you move from left to right. This is quite understandable. This is very easy also, because if you look at this, if you move from here to here, because periodic table has to be read like this, right? So if you move from left to right in a period, you will see from metals, slowly and steadily you're moving towards non-metals. That means the metallic nature, it goes on reducing. Now, similarly, the same properties, if you look for a group, that means in a vertical way, the valency. All the elements in a group shall have same valency because there will be same number of valence electrons. All right. Now, this is interesting, right? In a group, if you see in a group, that's how we have put them on the basis of their physical chemical properties. If you look at this, look at fluorine, chlorine, bromine, you will see Cl minus 1. That means the valency would be exactly same. Same here. These will have almost zero valency because they have achieved their octet. They would not react. Similarly, if you look at any other thing, lithium, sodium, potassium, you will see +1 there, right? Na +1. So the valency would be same in a group. Apart from that, when you look at the atomic size it grows. Means when you move down in a periodic table, the atomic size will increase. This is quite understandable. It's quite obvious also. If you move in this direction, the atomic size will increase continuously. And similarly, if you move down in a group, the metallic character of element, it increases. It increases as you move from top to bottom. Meaning from top to bottom, you'll find the metallic nature, it increases continuously. It increases. Metallic nature increases. All right. So these are some of the basic properties. Apart from that, let's look at some of the other things. The noble gases that we have, right? Helium, neon, argon, krypton, xenon, radon, right? They have zero electronegativity. That means they are extremely stable. They do not accept any electron. They do not lose any electrons. So they have achieved their octet. Apart from that, these are called noble gases. Apart from that, there are 118 elements in our periodic table. Out of that, about 98, I wouldn't say 98. This is again, this is a number that NCERT gives, but somewhere around 90 to 92 elements are the ones which are found naturally. They are found naturally, and about, I would say, 26 to 28 elements, they have been synthetically prepared. All right. Apart from that, the lightest element is hydrogen, and the heaviest element is organoson. This is Og. You will find it here. Its number is 118. Organoson. Just remember these, some of the facts. They might help you in the examination. But again, from chemistry perspective, do not focus on mugging up, or do not focus on remembering the periodic table, right? That's the basic discussion from the periodic classification of elements. Now, if you have liked this video, you can always follow me on this particular ID at Rahul Sai 222. If you have any doubts, any queries regarding preparation also, if you have any doubts, queries regarding the P2I program also, you can always message me on Instagram. I do respond on Saturdays and Sundays. Thank you for watching this again. Jai Hind.